Let's talk about matrix inverse rules. The inverse of the n by n matrix A is the n by n matrix A inverse, such that A inverse equals A inverse A, or the identity matrix I, which will be an n by n identity matrix. Okay, here are those matrix inverse rules. The inverse of A inverse is A transpose inverse is A inverse transpose. The next one's a little tricky. Notice that the inverse of AB is not A inverse B inverse, it's B inverse A inverse. And here's why. Notice that when you multiply together B inverse A inverse times AB, these A's will cancel out. That'll just be the identity matrix, and you're left with B inverse B. But B inverse B is just going to be the identity matrix. So notice that when you multiply these two together, B inverse A inverse and AB, you get the identity matrix. That proves that AB inverse, the inverse of AB, is going to be this matrix and not A inverse B inverse. Sometimes we call it the shoes and socks theorem. Okay, if first A is like your sock, and then B is your shoe, and then when you take it off, you got to take off the B first, and then you take off the A. So when you take off your shoes and socks, first you take off your shoe, and then you take off your sock. Similarly, ABC inverse will be C inverse, B inverse, A inverse, etc. Tangential comment, trace of a matrix, it comes up in this section. By the way, the trace of an n by n matrix is the sum of the entries along the diagonal. So for example, the trace of A is going to be 1 plus 4, in other words 5.